Drawings. There are three types of working drawings out there. There's detail, assembly, and installation. You can think of DAI, D-A-I. And then detail will be a description of a single part, but it's going to include enough information to allow the part to be manufactured or made, fabricated. Assembly is a drawing that shows the way various detailed parts are put together to form an assembly or subassembly, such as like the landing gear. It will have all the different parts of the gear in that assembly. And then installation will be a drawing that shows all of the parts and subassemblies brought together, but specifically on the aircraft. So it'll show how it goes together on the plane. So assembly is all those parts coming together to make one assembly or subassembly, and then how that assembly goes onto the plane, install. There's exploded view drawings, which will often be in your illustrated parts catalogs. It shows all the many different parts and where they go to come together. There's a pictorial diagram, similar to a photograph, shows an object as it appears to your eye, but is not satisfactory for showing complex forms and shapes. We have schematic diagrams. They show relative or functional location of all the parts in a system, but doesn't actually give location on the plane, the size or shape relative to each other. So a pump will look the same as, say, a tire, even though the pump is 10 times smaller. So it's not going to give you a good size. It doesn't necessarily say where on the plane it is, but relative to other parts. Doesn't necessarily show the shape. So yeah, we use these schematics for troubleshooting whenever a system malfunctions. Sketches are a simple drawing made without the use of tools. So it's easier to do a sketch on graph paper where dimensions are easier to visualize without using tools such as a ruler. Electrical wire diagrams show the wire size required for particular installations. And they kind of function like a schematic. They'll show you the wire leading up to different parts, but not necessarily where those parts are on a plane. Types of drawings. Measurements should never be scaled from the aircraft drawing because the paper does shrink and stretch during the printing process. So the print is seldom the exact size as your original drawing. When a detailed drawing is made, it is carefully and accurately drawn to scale and dimensioned. A sketch is a simple rough drawing made rapidly without much detail. A sketch is frequently drawn for the use in manufacturing a replacement part, and such a sketch should provide all necessary information to those persons who must manufacture the part. So they need to know the material, the sizes, the distances, but it doesn't have to be perfectly drawn like what you would see in, say, an IPC. FAR 91 has no requirements that a detailed dimensional sketch of a repair becomes part of aircraft record, but a simple sketch is often needed to help a mechanic make a repair, a new design, or a modification. Steps in drawing. In making a sketch of a repair, the first thing you're going to do is block in your views, so you're able to organize the sketch so it will clearly show the most information. Then you'll add your details, like where the holes go, and then you'll darken your object or visible lines, and then sketch your extension and dimension lines. Some objects that are typically used for sketching are triangles, circles, cubes, cylinders, cones, and spheres. I always say think T, C4S, because there's 4 C's in there. So T for triangle, 4 C's, circle, cube, cylinder, cone, and sphere. Aircraft reference points. We have the datum. This is an imaginary line determined by the manufacturer from which fuselage station numbers are taken. We call it our 0 reference point, and it will give you a fuselage station number would be inches from datum, either fore or aft. And if it's fore, it's going to be negative, and if it's aft, all the numbers will be positive. Usually manufacturers have been placing datum off the aircraft so that all the numbers are positive. There are still older aircraft that have a datum at such a firewall, in which case the engine would have a negative fuselage station, and then the cockpit and behind would be all positive. So remember to look at your type certificate data sheets to find where datum is. Station numbers is a numbering system used on large aircraft assemblies for aircraft to locate stations such as fuselage frames. Like fuselage frame station 185 indicates the frame is 185 inches from datum. Zone numbers are used on really large drawings, used for manufacturing aircraft, and are zoned to make it easy to locate parts, sections, views on very large drawings. It's kind of like if you ever went on a road trip and used an old school map. They have like ABC on one axis, 1, 2, 3 on another axis, and you have to match it up to find the area that your city's in. So that's how those work. Zone identifiers are placed every foot along the edge of the drawing, and the identifiers along the bottom of the drawing are numbers, and those up the side are the letters. Lines and symbols. Finishing marks identify those surfaces that must be machined finished. It'll be like a check mark or a triangle, and it's got a number on it, so it tells you how smooth or rough the surface finishing is. Cast iron is frequently used to represent metals or solid objects. If the exact specification of a material are shown in the drawing, the easily drawn symbol for cast iron is used for the sectioning, and the material specification will be listed in the bill of materials or indicated in a note. Then we have a picture here of some lines. You can see the phantom line at the top left. It's long, short, short, long, short, short. And this will show an item that is not pictured or an alternate position of a part. So like if it was a piston, it would show the fully extended and dark lines, and then like fully retracted in the phantom line to show you that it moves and it's 2 different parts. Then we have the center line that's going to go through the center of an object or a hole, and that's long, short, long, short, long, short. If you look at the outline, it would be your visible edges, and it's just a solid line. Then we have a hidden line showing you that there's something hidden from your view, such as a recessed hole, and those are short dashes. Then you have the cutting plane, usually has 2 arrowheads with a letter to indicate that a slice was taken from that position. If it's revolved section, you'll see the image inside of the part. In this case, we have a removed sectional view. So it's like we took a slice of cheese or bread from that area and laid it out on the counter for everyone to see what the cheese or bread on the inside looks like. And that's where section AA on the right is. We also have dimension lines. You'll see the extension lines extending from the part, and in between there is 2 arrowheads which are our dimension lines, in between those arrowheads, we would have a dimension, such as 6 inches. We also have leader lines. That's where you have one arrowhead pointing to information about a part. Dimension, allowance, and tolerance. Dimensions are the measurements used to describe the size of an object. So it's the ideal or perfect size for your part. Allowance is the difference between the nominal dimensions of a part and its upper or lower limit. So it's going to give us the maximum and minimum. Allowance has two L's, so there's two dimensions to it, a max and a min. Tolerance is the difference between the extreme permissible dimensions of a part. So your maximum minus your minimum would give you your tolerance. I like to tell people to think about a roller coaster ride. In order to perfectly enjoy the ride, you should be 5'6". And it will tolerate 1 foot of difference, plus 6 inches and minus 6 inches. So we have from 5'6", 6 inches up, you would be 6 foot tall. 6 inches down, you would be 5 foot tall. So 5 foot and 6 foot is my allowance. The 6 inches up plus the 6 inches down is 1 foot. You could also go 6 feet minus 5 feet is 1 foot, and that is my tolerance.